So far, you've learned about how to simplify square roots, how to simplify cube roots, and then we've looked specifically about why do we care about square roots by looking at relationships with right triangles that help us. And then we've explored how the Pythagorean theorem relates right triangles' areas of their legs with each other, which allows us to either prove if it is a right triangle, and or if we know it's a right triangle, it allows us to find missing side lengths. Now we're going to learn how to apply the Pythagorean theorem in real life situations, because that's where we really care about using the Pythagorean theorem. So my first example is of a city park, okay? And the city park I'm telling you it's a right angle. Might not look like a right angle, but I'm telling you that it is surrounded by some streets. Okay, so here's the park. Okay, it's Triangle Park. I don't know if you have heard of it in Durango, but it's on 17th Street. And there are some streets, okay, that surround, whoops, my bad, that surround the park. Okay, so this is a street. This is a street. And this is a street. They allow you to go around the park. Okay, so I'm going to tell you that this street right here is 1.5, I'm going to use a different color, is 1.5 miles long. So from here to here is 1.5 miles. That is huge. This park is gigantic. All right, and we're going to say that this side of the street, we're going to make it 2 miles long. Is my drawing drawn to scale? I hope that you're saying no, okay? Because I'm just making this up as we go. All right? So my question is how long is that street? So it appears that I have a right triangle, and I know both of the legs, but I am missing the hypotenuse. So I can use the Pythagorean theorem, which says a squared plus b squared equals c squared. So 1.5 squared plus 2 squared is going to equal that c squared. It's not going to equal the length of c. It is going to equal the square created. That's not a very good square, but pretend that's a square. The area of the square created with the side length of c. So now I just do some math. So 1.5 squared is 2.25. 2 squared is 4, which equals c squared. So 2.25 plus 4 is 6.25 is what c squared is equal to. How do I eliminate the squared? I need to use the opposite inverse operation. So if I take the square root, that cancels out the squared. I have to take the square root of this side. So I get c is equal to whatever the square root of 6.25 is. That would be if I asked you what c is. I asked you for the length of that street. So I'm actually going to need to figure out what the square root of 625 is, or 6.25, which is the same thing as the square root of 625. So I'm going to do a prime factorization. I bet 625 is divisible by 25. So it turns out that it's 25 times 25. Okay. So there's my two groups. That was a good guess. The reason why I chose 25 is because it was made of 25, and I know that 25 goes into the hundreds of 6 as well. So 25 times 25 is 625. So that means that 2.5 times 2.5 is 6.25. Oops. 2.5 is equal to c. Still, I have not yet answered my question. I would need to go ahead and say the length of the missing street is 2.5. What's my units? Miles long. Okay. So there's an example of when we might need the Pythagorean theorem. In an earlier video, I'll show you another one, I talked about what happens if you... Oh, actually, I'll do a better one. I talked about using a rangefinder for hunting. Okay, so let's say I have a mountain. On the top of my mountain, I have an animal. Okay, maybe my mountain isn't really a mountain. Maybe it's just kind of a hill. And I'm right here. Yay! All right. Turns out that I want to know this distance, because this is the distance that I must shoot at. Okay. Maybe I know that the height of the mountain is 10 feet. And maybe I know that I am standing 20 feet away from that mountain where that animal is at, or that hill where that animal is at, and I want to know how far do I actually need to shoot in order to get that animal, or in other words, maybe you don't like to hunt, maybe you just want to know how far away that animal is from you. Pythagorean theorem, why don't you give it a try? Hit pause right now on your own, do this problem, and let's see if we end up with the same things. And I'm going to go ahead and talk us through this part right here because I'm actually simplifying this square root. So I ended up with the square root of 500, or the prime factorization of the square root of 500 to be 5 times 2 times 5 times 2 times 5. So that means that I can rewrite it as 2 times 2. I've got 2 2's, and then I've got 3 5's. I want to simplify this. So I need to get it, that could be 4. I like that because that's a perfect square. This could be 25. I like that. That's a perfect square. And this is not a perfect square, but it's 5. So the square root of 4 is 2. The square root of 25 is 5 times the square root of 5. So I'm just bringing everything down, simplifying it as I go. 2 times 5 is 10 times the square root of 5. There would be my simplified answer. So if I go back up here, it's 10 times the square root of 5 is equal to how far that animal is away from me. That doesn't really help me though, because I don't really have a sense of what that is, but I can estimate the square root of 5. It's really close to the square root of 4. It's really close to 2. It's a little bit bigger than 2. So I'm going to put my approximately. So 2 times 10 is about 20. Now we know that it needs to be greater than 20. Isn't that true? Okay, so it's an okay estimate for me to say 20 feet, but I should be a little bit more specific because this is going to be a little bit bigger than 2. It's going to be something like 2.2, which would actually give us about 22 feet. And that works because it's bigger than both 20 and 10. If I take the calculator and I actually find the square root of 500, I got 22, well, about, because remember I don't want to round, but the calculator told me that the square root of 500 is about 22.36, goes on forever, feet. All right, so there's just a couple of examples of how to use the Pythagorean theorem. Okay, the one thing I do want to do is solve one where I don't know one of the legs. Okay. So I don't know one of the legs. So I'm going to go ahead and scroll down, extend my page a little bit. Okay, So what happens if I do know the hypotenuse, and I know the hypotenuse is 2.9 centimeters, and I know one of the legs is 2.1 centimeters, and I don't know that other leg? I'm telling you this is a right triangle. That's why I can use the Pythagorean theorem to help me find it. So it turns out a squared plus b squared equals c squared. My c is the 2.9 squared. My b, let's make it be the 2.1 squared plus a squared. Okay, now I have to simplify both of my exponents because exponents come before addition. So 2.1 squared is 4.41. And 2.9 squared is 8.41, and that's I add that to a squared. What do I do next? Subtract 4.41, subtract 4.41. I gotta bring this down. A squared is equal to 4. Now what do I do? Hopefully you said take the square root because that cancels out. And I'm just left with a, but I have to take the square root of the other side. It is 2. So that means the missing side length is 2 centimeters long. All right. Hope this helped you to be able to apply the Pythagorean theorem. Our problems are going to get harder as we go. Have a good day.